Hey everyone, welcome to Live App Review. My name is Matt Lockyer with Near Protocol. So today we're going to have a continuation of Live App Review 2. So it's part 2 of 2. And we are going to continue with the social token drop that we were doing before. So just a couple of definitions to get out of the way. Social tokens are basically just tokens that you would drop to your community or your fans or anyone who's interested, really. And a drop is basically just dropping them. So you're rewarding followers on Twitter or people or fans who are in your forum or your Discord group or Telegram channel, whatever. So basically what we're going to do is in the first part, we focused on dropping tokens to users who have no Near account and no Near to pay for fees. So the experience that we want is really just like this. So you come to a web page and you don't even have to click this button that says get new account, but you just land on the web page and an account is created for you, some burner account. And you get this app key. So what is an app key? Well, it's an access key in Near Protocol that is actually added to the account of the application. So in this case, we are giving every user that we want to drop tokens to an access key on the application's account. But we're specifying a very small allowance in Near tokens, and we're probably checking against our backend server whether they're like a real person or we're going to make them authenticate through some third-party OAuth service. We didn't do that in the first example, but that's something that I'd like to show you today. So one of the things that we're going to do is we're going to authenticate the user before we give them one of these app keys. The other thing that we're going to do is fix up some of the contract balances stuff and make it's not going to be a standard fungible token on Near, but it's going to be a little closer to something that we can drop tokens to these app keys and then move them to an account and then have an account move those tokens to another account. So we're just going to clean that up. So we're going to also clean up, like in the process of doing that, we're going to clean up some of the front end interactions and stuff. So we're going to actually make a little bit more of a UI around that, and you'll see how to kind of interact with the contract with regular Near accounts, so accounts that can pay for their own gas fees, but also with these app keys once more. So let's get to let's do a quick run through. So we get this app key. So how does a token get dropped? Well, you just come to a website and this step is already done for you. So in the background, totally hidden from your user, you have created them a key pair for this app key. And you're going to allow the user to, after some backend authentication, you're going to allow the user to claim these tokens. So you're going to claim drop, and then your drop tokens should appear here. So my drop tokens went from 0 to 100. And now you're going to transfer drop tokens to a token ID, but we have to set a receiver first. So let's set a receiver. So this is a separate account up here. This was just an account, a temporary account that has no Near that was created for me on the page. Just really quick, I do have to draw the distinction once again that the seed phrase and implicit account ID, just like in Live App Review 1 and 2, the seed phrase and implicit account ID are completely separate from this key pair. So it's a complete other set of keys or whatever. So I'm going to actually just drop to the implicit account ID because I want to show that this account has 0 transactions and no Near tokens, so it can't pay for gas, but it can receive these tokens from a user that just landed on a web page and got a key pair to claim tokens. So once again, we've claimed tokens without paying for any transactions. and we're going to receive the tokens without paying for anything. So we're going to check the receiver balance. Oops, it's 0. We're going to transfer the drop tokens to the account ID. So they're going to go to 0 here, and they're going to pop up 100 here. So the receiver tokens are 100. Great. So now if I refresh the page and I don't have any information here about the receiver, but I put in the same account ID, I can see that I have 100 tokens. So reading that information out from the blockchain is super fast. So once again, I could now, with only having this seed phrase and without having any near tokens, I could pop up on a separate website, completely different website. And as long as it had the same JavaScript, it could basically read out my token balance as the receiver of those 100 tokens. So that's pretty cool. So now we went from kind of one user with a key pair claiming the tokens to an account that had no near that now represents as basically is representative of having the tokens. So that's pretty cool, but we can do better. So there was a flaw actually in the contract. So if I create a new app key for the user, I don't know if it worked or not. Come on. Oh, something's up with my server. Pending transaction here. Yeah, there's something going on with RPC or testnet. So let's just give it a sec. Or we could just kid it. Okay, well, we'll see what happens. Something's up. Transaction's a little stuck, it looks like. Interesting. Oh. Maybe it's my internet, but we will see. Here we go. Okay, so I've cycled my access key. So I basically got a new access key. So remember that this receiver has 100 tokens. Now, if I claim tokens as a different user, so I've landed on the page, and once again, we're going to do this today. I've authenticated with a backend service, so the server checked out my Twitter account or whatever and said, yeah, it looks like it's you. And then they basically allowed me to add an app key based on my Twitter handle. That would allow me to claim tokens, and then I could send them to somebody. But what happens if I or my friends, like we both send tokens to the same person or the same account? So I say to my buddies, hey, you got a Twitter account. By the way, app developers, this could happen to you. I say to my buddies, hey, you all have Twitter accounts, or I have some ghosty anon degen Twitter account. I could basically claim more tokens. So let's say that I did, right? So I claimed another drop of 100 tokens. But here we have a problem in the contract. So we have a problem because when I transfer the drop tokens to this receiver, it actually is not going to go to 200 like you would expect. It's actually just going to go to 100. And that's because there's a flaw in the contract. So first things first, we're going to fix that flaw so that when these tokens go to 0, these tokens go to 200. Looks like the transaction, something's up with my internet. Oh, there we go. So it went to 0 and these tokens stayed at 100, which is not good. So let's go fix that in the contract. So that's the first thing we're going to do. So here we had the drop. So there's nothing wrong with claiming the drop tokens, and there's nothing wrong with restricting the user if they've claimed the drop before. So actually there is something wrong with restricting the user if they claim the drop before, because we removed them from the drop tokens array. So we have no record of having dropped them the tokens. So you can claim 100 tokens again. It's actually kind of funny. But once this balance is 100, we claim drop again, and it's going to give us a warning. Okay, and that's because the smart contract panicked. So let's make some adjustments that make it a little bit more robust. So the first thing we're going to do is we're not going to remove the drop tokens there from the when we transfer them. So when I transfer tokens from the I'll go to the mappings here. So this is the only real sort of storage in our contract. So when I transfer tokens from dropped to tokens, so the tokens that were dropped to the app key, and I transfer them to the account ID, as you were seeing me do here, I was actually removing the record of the tokens having been dropped in the first place. So if I do that, you're going to see how that affects my application here. So first, I have to, first order of business is I have to stop my server, sorry, not my server, stop my app. I have to test and deploy the contract. So I'm basically going to get a whole new test account. I do have to actually stop my server as well. So I'm going to run some tests on the newly compiled contract that doesn't remove the record of the drop tokens. So we should be saying tokens already dropped. Oh, that's a good point. The balance is 0. So instead, what we actually want is we want to do, we can't do this actually. We actually have to do this here. We have to change more. So we have to check the result of the public key record here. And we have to, oh boy, it's actually going to be a little bit more of a fix. I just realized that. So what we have to check is we have to check assert balance we actually need it to be is none. And then we're going to warn that the tokens are already dropped. And then here we're going to do so if it is none, then let me think about this. Yeah, we only want to drop the tokens if it's none. If it's not none, we're going to say tokens already dropped. So that's it. Yeah, so that's it there. And then we actually didn't insert properly the updated balance. So we actually have to insert balance here. Let's hope this works. I should really just store that as like a const somewhere because it's used everywhere. Let's do that. Handy dandy 0 const. Okay. Let's move through here. Don't know if I need to have the reference, but we'll see. It's probably going to scream at me. Whoa. It didn't like that. Oh, yeah. Oh. You're getting it. I think we can do that. I'm not sure. We we probably want to do the same check here. But instead, we're going to switch that. Is some. What was the error there? No tokens. It's important we have the same assertion because our unit test depends on it. Yarn test. Oh boy. Okay, so Oh yeah. Insert, insert. It like that, and we moved the balance here over here. Now, when we transfer the tokens, moving the balance, that's going to be a problem. We're going to have to change the contract anyways. I think at this point we know it's some value, so we're just going to unwrap. And it expects a... Oh, that's in the test. Okay. Test 109. That's really weird. Right. Oh, we'll just do this. Okay. One more. Nope. This is really weird. Okay. Pretty sure I've done that before. Okay. Oh. I mean, that is the type. Let's see. There we go. Okay. So those unit tests work. We've juggled a bit of the logic here. So first things first, we have to check if the balance is none. And then only if the balance is none, or sorry, if the balance is some, then we would say the token is already dropped. So we will never drop tokens if we have a record of a public key in this map. So whether it's 100, whether it's 0, whatever. We will be able to transfer tokens if there is some balance in here. So if there's no balance, then we aren't allowed to do the transfer. Actually, I liked it before. It was an unwrap or and then a check against 0. I think that's better for transferring the drop tokens. I'm just going to go back really quick and I'm going to update that. So what we're going to do is we're going to... Oh, that's the test. Okay. What we're going to do is we're going to unwrap or 0 and then assert that the balance does not equal 0. So we definitely want to have some tokens before we transfer tokens. So we're just going to say, if there's no balance, it's going to be 0. And if there was a 0 balance, it'll be 0 anyways. And we're going to check against 0 and blah, blah, blah. The unit test should all be fine. So now we insert a 0 balance. So if the balance wasn't 0, we insert a 0 balance where the tokens were dropped. And I think we check that too. We should have a test actually where it says no tokens. Oh yeah, there's a test where it says no tokens, but there should be a no tokens after, like a double pump on a transfer. So let's do contract drop before we do transfer. Okay. So we do contract drop, and then we do transfer to Bob and transfer to Bob. And that should also say panic in this method. It should panic here at no tokens, because Alice, the person sending Bob the tokens, should have a 0 balance. What are all these weird errors? Oh, 57. Weird. Oh, yeah, I had a leftover here, the balance unwrap. That's not going to work. And, oh, it's a same name error. So this is a double transfer panic. Okay. The unit tests look like they're good. So the one last thing we want to figure out is when can I transfer? So I have to actually change this. When can I transfer from account to account, right? So we actually want to add that. I don't want to come to the back to the contract and have to redo this. So I basically want to add like a transfer method to transfer from account to account. So and I probably want to do the balance too, some amount. I'll just do the stick with the U128 type, just for fun. Okay, so here we're checking tokens and we're checking account ID. Actually, no, that's the receiving account ID. Here we're going to get the sender as an account ID, and we're going to get it from the signer account ID. So not the signing public key, but the signer account ID. And then we don't need to actually check this. That's because we are probably not from the app. We're like a wallet. We're some wallet account. So then the sender, we need to check the sender's balance. So self tokens get at sender, on that anyways. Then assert that the balance is not 0. And then also assert that the amount you're trying to transfer is less than or equal to the balance. I'll just say no tokens. Or no, well, it's going to be better if we say not enough tokens. And then what we want to do is we want to say token sender go down, and in that case we do balance. We have to do some, like, we should do some like safe math blah 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 here, but we're not going to do it. And we're going to do okay, so the account ID is the receiver. So here we have a transfer of actual tokens from one account to another. So I'm going to write a quick test for this. This is going to be a little messy. These all need to change to be transfer drop now. So this person is now transferring their drop amount, right? So we transfer drop, transfer drop. So all those tests are transfer drop. Now transfer tokens is actually, well, first you transfer the drop to Bob, and then you do a transfer. We actually have to reset our environment context. So we have to set context signer account ID to be not going to be Bob anymore. Oh no, it is going to be Bob. So Bob's the signer now. Bob is the signing account ID, and we're going to update that. So now Bob, when Bob transfers, Bob's going to be the signer, and Bob is going to transfer to what's the next person in the cryptography people? It's Carol, I think. And then we're going to check Carol's balance. Kind of annoying, all the two-string methods. Oh, whoops. And we also need to transfer the amount to Carol. Let's transfer the whole amount. We could write a whole bunch of tests that would test this, transfer this amount, transfer that amount, blah, 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 blah. Okay. Ooh. It doesn't like that operation. So that's going to be a little bit annoying to do the conversion. Oh boy. Or maybe we have to do. I don't know why we can't do math on that type actually. Let's do. Maybe it's just like a weird Rust thing. Again, I'm not a Rustacean. I'm not a Rust expert. Okay. So let's do some weird stuff and try to just kind of force this. Let's just force the types, force the math. Probably gonna scream. Oh, it didn't like that at all. Ascription, type ascription is experimental. That's pretty weird. What if we did this? Yeah, just layer it up. This is just me having fun with Rust. That's pretty garbage. So here's what we're gonna do. We are doing stuff like not equals and in assertion. For some reason that's fine, but it doesn't like any of this math stuff. So let's do this. Ah. Oh, we can't change the type. No, I think that would be so. Let's just make it a number now, and we'll cast it back later. This is how fun Rust can. I'm probably gonna get laughed at by some Rust expert who knows way better than I do. Come on. But I just want to work with numbers. Oh boy. That should do her. And it hates me. All right. Yeah. You like it, don't you? All right. This is so fun. Anyways, I'll leave that in the video. Yay! All right. Okay, so we got a transfer of regular tokens. I knew it would work eventually. So we actually, oh, this is actually transfer drop test, and this is transfer, but oh, whatever. Okay, so let's run those one more time. We're good, and there are the panics, but the panics are expected. Okay, so now that we're done with the contract, we have an extra transfer method. We're completely done. We're out of this contract, I promise you. Yay, no more Rust. So now let's test deploy and make sure our app tests work, but we're going to update those app tests. We're going to have to change two things. First, we added a new method to the contract, so we have to actually change the contract config here. We have to add transfer drop, and we also have to update our tests to be doing a transfer drop. Now, because I want to skip to the app stuff, I'm not gonna write any more app tests. I'm just gonna test the app tests that were there before, and then we've already deployed the new contract, so we're gonna rush to the app side of the example. You can see as I furiously suck back my coffee. So these app tests should work. Deploying a new contract and deploying a new contract account. So I actually have to shut down the server and shut down the app. So the reason I have to shut down the server, shut down the app, and because the contract was redeployed, is that the new contract name is going to change for config. And when the server starts up and when the app starts up, they pull the contract account out of this config file. And they also need the new change methods here. So remember, we can get the balance of drop tokens, and we can get the balance of tokens from a regular near account. Okay, so let's take a look at what happened here. So we ran the tests, and these tests were not fully complete. We do not have a test where we transfer tokens from one full near account to another, but we will do that in the app by signing in with our wallet and then using our wallet to transfer tokens to another user. So it's going to be cool. Trust me, just hang on. Let's reboot the server and the app. Okay. So 3000 and 1, 2, 3, 4. Keep it simple. Don't get crazy. So once again, the first thing we did was we changed it so that this app key cannot continually claim tokens even if it's already transferred its tokens out. So we changed the logic there to prevent the key from continuously claiming tokens. Now, why do we want to do that? Because as a server on our backend, we're going to authenticate people, and we're only going to give one person one key pair. So we don't want that key pair to continually be able to claim tokens, right? So let's, since we redeployed the contract, this app key is no longer valid. So, but I think this account is still okay. So let's get a new app key. So that's kind of a cool app key. AMSIF. Okay, so let's claim the drop based on this app key. So remember, we're focusing on not being able to drop more than 100 tokens ever using this key. Ever. Okay, so I'm going to check the receiver balance. Oh yeah, transfer the drop tokens. So again, I'm still using this key. Oh boy. Oh, missing field amount. Okay, so why is this happening? Well, think about it. On the front end, we're still calling the method transfer. Remember when I renamed it to transfer drop? Okay, so we got to go in and we got to fix that. So that would be in the contract component. Handle transfer. Actually, let's rename everything. Handle transfer drop. Always a good idea to just rename and refactor everything, right? No, don't do that. Let me just double check. Double check anything contract transfer, anything around. No. Okay. So we're going to save that, reload. So we still want to transfer our drop tokens. So we still have drop tokens in the app key. So the app key still has a claim to those drop tokens, and it can send them to whoever they want, and the app is paying the gas fees for that transfer. So we're going to transfer the drop tokens to this other account. Remember, this account up here is different than this app key. So now this account up here has the tokens. Now we have 0 tokens claimed by this app key, so we should be able to claim again, right? But I don't think we will be able to, because the contract is now, we are no longer removing that record when we transfer the drop tokens. We're keeping a record of that public key having 0 tokens. So the tokens are already dropped. The value is 0, and we know that that public key has some value, and the value there is 0. So let me show you the part of the contract there. That is a assert is none. So if the record was 0, there would be some record of a public key up here in our unordered map. There would be some record of a public key mapped to a UIT. So that's the logic that prevents a public key from ever claiming any more tokens. Okay? So now what we're going to get into is the interesting part. We've transferred the drop to an account. Now the interesting part is we want to sign in with the wallet, actually. So we want to drop to a real wallet account, sign in with the wallet, and then let the wallet transfer their tokens from account ID to another account ID. And then we get to check the balance of that account ID. So really, we're going to get started with the app part right away. It should only take another 10 minutes, and it's pretty cool, actually. So once again, recap. Some user came to our website. Forget about this stuff. Some user came to our website, and we gave them an app key. So we just gave them a key pair. And we said, congratulations. First we verified them on our back end, which we should do, and I hope I can do in time. We verified them on our back-end server. Then we added this app key to the app contract account. Then we let the user claim the drop tokens, and then we let the user transfer those drop tokens to whoever they want. And now what we're going to show an example of is when an account has received the drop tokens, they're going to transfer them to another account. So remember, the first steps are all happening without the user having any NEAR or knowing about NEAR or anything like that. So let's go to the, we need to basically, where should we put this? We should put this in the, I think what we're going to do is we're going to put the claim drop and transfer drop tokens. Then the receiver gets the tokens. Check the receiver balance. We can do that all day long. I think what we're going to do is we're going to put it here. So we're going to put another. We're going to put another part to the component here. I'm just going to kind of separate this. Again, not the prettiest UI, but we want to make sure that everything works functionally. So we know how much the receiver has. This receiver has in tokens. But we want to check, probably we want to call it like the wallet account. So wallet account tokens. And for that, we will have to actually bring the wallet account in here. And we're going to have to do some magic there. We're going to see if the wallet account has a balance of tokens. Let me think about this for a sec. And then we're going to have the option to transfer those tokens. So we are going to have an input that's going to basically, we'll just set the receiver, and then we'll have something we can set an arbitrary amount. So let's add that to our state. I'm reusing a lot of these state variables from the tokens that are dropped and transferred to the tokens that are going to be sent from the wallet, but not advisable, but I think it'll be okay because we're doing these in separate steps. So account, amount to transfer in NEAR. And then what we're going to do is we are going to handle transfer. Yeah, handle transfer. So we're going to set the receiver and set the amount, and then we're going to call a function called handle transfer. So I'm just going to copy this one, and I'm going to call this handle transfer. And I'm going to do some checks like this, set a receiver. We have two fields setting a receiver. That's going to be a little bit weird. That's not weird. We'll just see double. No problem. Check the amount. Maybe like does not equal 0 or something like that. And let's make the default 0. And just make sure that just some checks here. So now we need to get a get a contract account, but remember we don't have any idea what the wallet is or what the wallet account is. So we're going to go to app.js, make sure that the contract is aware of the wallet and the account coming from the local state. So we got to make sure that the person's actually signed in. So I think I can get away with it just being the account object here. So some other checks. We shouldn't show any of this to the user if they're not signed in. So I'm going to hide this if there is no account. Just quick format there. And if no account, so if account is null, we're going to hide that. And let's check it out. It's still showing. So we obviously have some account there. Are we signed in? No, we're not signed in. I don't know what account object would be there. Undefined, right? Oh, whoops. Let's only show it if we actually have it. So again, this is the same part that we had before. I'm just gonna make this a heading too, because this is confusing me. I want to keep these sections broken up. So we have the sign in with the wallet. So if we sign in, we should be able to see that token transfer zone now, the new section that we added. So I'm going to actually specify, I have a real problem with these testnet accounts. I have my friend si1.testnet. I don't know why I like that, but I do. So I'm going to log in with that account. Okay, so now I'm logged in with si1.testnet, and I can see some information about my account here. So what the wallet account is going to show us, hang on one sec. We need to have one more state variable here. We need to set that, and then we need to we should just check the wallet account automatically. So if we mount, we should just check this is going to get a little hairy with all the accounts and variables floating around, but it's just a simple copy of this method, so I'm just going to copy it. But this is a good precursor, so we're going to check the balance of account. So if there's no account, we'll just return. We won't do anything. And then we'll set the balance of the wallet tokens to be the get balance tokens of that. So that should be okay. Probably do that now. Okay, so we're going to check the wallet, and if we have an account, we're going to check it, and then we're going to check our balance of tokens. Let's see if that works with no errors. We have a connected wallet account. I'm still logging it out here. So we're checking the balance, and the balance is still 0. Now we can set the receiver here. Like, it doesn't matter that those are the same, because we're only going to use one at any given time. So the key here is that we're going to now drop tokens. Instead of dropping tokens to this arbitrary account, we're going to drop tokens to the wallet account. So I don't know if it's going to work, but let's see. Remember, we shouldn't be able to claim tokens with this key already. We have already dropped it. So we're going to get a new app key. So we're pretending that we're a new user, and our backend should have authenticated us. So now we're going to claim the drop tokens to the new user. Okay, so we got 100 tokens there. Now what's my account ID? I'm going to be the receiver, and I want to drop tokens from using this app key. I want to drop tokens to si1.testnet. So I'm going to transfer drop tokens. and the receiver tokens are 100. Now, why are the wallet tokens not 100? Because we only checked the wallet after after mounting the component. So we never checked the wallet after the transfer drop. So we could do that here, and we'll fix it for next time. Oh, and the hot module reloader just reloaded this and showed me that I had 100 in the account, in the wallet account. So if I refresh the whole page and I come back to this app, my wallet that I'm signed in with has 100 tokens. Yay! So si1.testnet actually has 100 tokens now. So if I want to send tokens to this account and I want to send some arbitrary amount, again, never mind the double entry here, I can send tokens from my wallet to that account. But let's just double check to make sure that we did this transfer properly. Okay, so get contract wasn't filled out with an account. That's a problem. And remember, I had a check here to make sure that there was in fact an account. I probably just want to throw that at the top of my handle transfer here. I'm also going to get rid of that. And I'm going to check, not only am I going to check the drop, check the receiver, check the wallet, I'm basically going to do all these checks after I transfer the tokens. So when I do a transfer from account to account, I have to specify the receiver and I have to specify the amount. Now remember, when we write in an amount, oh no, we're transferring tokens, not near. So we're actually going to transfer the amount of tokens. So the tokens have no decimals. Normally, if I was transferring near, I would have to like parse the near amount from what the user put in. And in fact, this is a misnomer now. It's amount to transfer in tokens, not near. So I'm going to save all that, and I'm gonna set that up. So this is a token transfer from a wallet account, not one of these app key accounts. So it's not like a claim drop tokens with your app key and the app pays the fees. I'm actually paying the fees. So si1.testnet, let's bring that up actually on the Explorer, and let's check the gas for si1.testnet because we want to see that happen. So here we have 481-38165. Okay, so let's remember this number. And so it's like 38165. Okay, wow, here we go. Let's do this because I can't remember that stuff. Okay, so quick recap. We have tokens in our wallet account now. And now our wallet account is going to transfer to anyone. So I'm just going to transfer to this person. And I'm going to transfer 50 tokens. And I'm going to send tokens from my wallet. Oh, it says set amount. Doesn't like that. I probably copied an input from somewhere. Set amount to transfer tokens. Let's check here. Oh, a little logic for you. Gotta love that. Boolean logic in the morning. Okay. Let's set that to 50. So we're going to transfer 50 from the wallet account to the implicit account that was loaded in the page, but we didn't really use. We're going to send tokens from the wallet. Let's hope it works. And then we're going to update all the balances. Retrying transaction. Right at the moment of truth. Oh, look at this. So the receiver has 50 and the wallet account has 50. Remember that magic number? Oh, it stayed for me. Let's refresh. Look, the gas went down. So I actually transferred from the contract from my wallet account, and then I transferred to another account that has no near. Awesome. So there's 50 tokens locked in this account. It has no near. So last thing that I promised to show, that I will show, is I am going to sign out of the wallet. I'm going to remove this account, tear it all down, and I want to show you an example of what you would do with your server if you were trying to protect against people people coming to your website and saying, "Oh, give me more keys, give me more keys," because they want more of your token drop. So you need to add something called middleware to your server to protect against people adding too many keys. So I'm going to do a very rough, a very rough in-memory sort of middleware here to protect against that. So I'm just going to put it, I'm just going to call it keys.js. And I'm also just going to go and going to, I don't really need anything from here. I just need the general sort of outline of a method here, and I'm just going to start from that framework. And I'm basically just going to say key exists, and then I'm going to store an in-memory mapping of keys here. So again, you want to keep track of the keys to which account people are adding, or if the keys have been added at all. So let's say I'm gonna skip. No, sorry, that's not true. You can't skip doing the OAuth step. But let's assume that I'm gonna check. Let's do this. Let's create a pre-list of authorized users. So Matt, and we'll just make it, null. So let's make, is it authorized? No, because you could just add any old account here. So let's say we're gonna have to skip the step where we actually go get the user's authorized account. So we'll assume that what can we take from the user? We'll just assume that they've sent us we'll assume they sent us a JWT token. Okay? So we're going to assume they sent us a JWT token, and we're going to assume that it's valid. I'm just going to rip this from here. So we'll assume that we have some token from the request body that the user produced by doing an OAuth verification. And then what we're going to do is we're going to check the key that they're trying to add. So that's public key. And the keys here is going to be an in-memory store of, basically we're going to go from token to public key. So just for fun, why don't we just do this? And that'll be like a way to remind us here. So then we're going to say if no keys at token, then next. Oh no, we should just throw out of here. I'm just gonna get an example here. All right, and we'll do next if we get through everything. Okay, and we'll just say error key. We'll just say, user already has key. That's going to be terrible, but whatever. Oh, and we have to update keys token equals public key. So if there's a key at the token and, oh, we don't even need public key. Cool. So that's a little in-memory mapping, and then we just want to, I always forget the node stuff. That's bad. So we just export key exists. So this is just going to be in memory. It has nothing to do with the database. There's no persistence. There's no nothing. So this is terrible. It's really bad. But this is what you would do. You would add a middleware keys, and then you would go key exists. You would add that here. So also we probably want to say if there's no token, we want to spaz out. So if must provide valid token. So here you would also check the token. So I'm just going to put a big block comment. Check token against third party service to make sure valid. All right, you got that? Okay, that's your job. And then on the front end, so we have to now, when we add keys, we can't add keys without specifying a token. So the server's up, and we're going to get a new account. And it said something happened. Try get new app key again. So it said response, blah, 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 forbidden. Okay, so go to network, check out add key, must provide valid token. Oh no, man, we got stuck here. Okay, so we don't have a token on the app. So we just need to pass in some BS token. And just to keep my life simple, that's under the keys component. Okay, just to keep my life simple, I am going to pass in some ever-changing token. And remember, the tokens aren't being checked, but basically I'm just going to pass in like the classic. It's the gold standard of random pseudo UUIDs for JavaScript apps. They're not UUIDs. I am aware. So we should be able to add a key now, and it all worked. So yay, we added our middleware to our server that protected against somebody adding the same key over and over again. I can prove that actually by just saying that my token is Matt. So if my token is Matt, I should be able to get a new app key once, but not twice. Oh, it's failed over here. User already has key. So that's another failure in the middleware to show you that we actually did fail properly. Okay, so once again, you would actually have the user authenticate with a third-party service client side, like a Twitter OAuth or a Google sign-in or whatever. Then you would send them back to the app and you would check that token against the server. Then you would store the token probably in some database. And that's your job, persist in DB. So you would store this kind of a mapping in a database, and you would not let users add keys for accounts that they already added a key for, because otherwise they would be able to go add key, add key, add key, and claim drops, just like this. Claim a drop. Oh, I have to get around my own middleware now. Okay, claim a drop, and then get a new app key. Claim it. Oh, whoa, I removed the account. Okay, let me get back. All right, make a new account. And then claim drop this new key, Tuso. And then get a new key. Oh, this person is really, they're attacking my social drop. Wah. Okay, so you get the point. Basically, if you allow people to use many, many different tokens, your middleware should basically protect against these tokens being used here by persisting the token mapping in the DB and checking against the DB, and then you check the token against the third-party service, and also you check token against your database. So you check to make sure that the token is valid, then you check to make sure that they've never used it again. You probably will actually want to do this one first. But whatever, it's up to you. So check your database. They have never used the token before to add an app key, and then check against the third-party service. Okay, I'm really out of time. That is it, and I hope you enjoyed live app review. All right, and again, Repo and all that good jazz is in the description. And oh, by the way, One more shout out. I tried to do this last time and I didn't know where I was going on our own website, but check out near.org. And if you want to join the community, check out the Discord where you can find me, and you can check out the Telegram, but I'm not there that often. You can tweet or WeChat or whatever you want to do. And for developers, there's lots of goodies in here, and you can check it all out. We have lots of docs and lots of great stuff. And yeah, just scoot around. And there's lots of, in a community as well, there's lots of opportunities to get involved and earn some tokens. So you can contribute, lead a guild, which is like leading a community, come to our events. We're going to be at East Denver, which will be great. And we're at a lot of online events, and we have a big growing developer community. So come check us out, earn some tokens like this little guy, ding, ding, ding. And I hope you enjoyed. Thank you very much.